Hi, this is Jason, and this is my sprint to retrospective. In this sprint, I played a role in testing the application. Let's go to the application. So this is the current working application which we have, and this is the seasonal view part of the app. So if the user selects a particular year and a season, the web application goes to the backend and fetches the netcdf file and plots the heat map in the screen. So it's really important to validate this. So to validate this, what I did is I wrote a code which takes a year and a month as an input. So right now it's limited to 5 year and a month combination. So if I enter a year and a month here, it actually generates the netcdf file for that particular season and it saves it in a folder. And I validated it with the help of an application called Panoply. So if I open Panoply and if I select a particular season and if I plotted it, it gives us an actual depiction of what the heat map is supposed to be. So if we have a look at the pattern generated here, and if we go back to the application and see the pattern generated here, by comparing these two patterns, I made sure that the results produced by the application, it's pretty accurate of what it's supposed to look like. I also tested the Enzo and IRD part of the application. The Enzo and IOD are the climate drivers here. So user get to select a particular climate driver and gets an option to select the highs and lows of that specific climate driver. And he gets to select the specific duration between the climate driver is present. So let's say if the user selects 1900 to 1902 and the phase is El Nino. So what happens is it goes to backend and selects all the values. So it goes to the backend, which is this part, and it goes to the Enzo CSV file and selects all the value which is greater than zero point 0.5 for that specific year duration. And to validate this, what I did is I manually selected all the seasons which fall under the particular year category and which falls under the specific uh, phase. And with using this code, I plotted that netcdf file, and using Panoply again, I make sure that the data which is produced in the screen, it's accurate to what it's supposed to look like. Along with the testing part, I also worked on the UI of the application, which follows the color code theme of FedUni, a blue and white combination. This is in the end UI. I still have to make some tweaking to the UI part, but this would potentially be something which the application will look like in the end. And I also worked on 90th percentile extreme weather calculation in the web application. So this is still in the development phase. So what it is, so let's say if the user selects a year range between 1900 to 1910, let's take the 10 years. So we'll be setting a threshold by sorting that 10 years FFTI heat map values. And the threshold will be something which will be in the 90th percentile mark. And we will be taking all those extreme weather which surpasses the 90th percentile mark, and then we will correlate with the Enzo values, which each season will be associated with that specific Enzo value, which is over the 90th percentile mark. And then with that information, we will plot a map which will be ranging from minus zero point 0.4 to plus zero point 0.4 Enzo value. This is something which I worked on Sprint 2 and still in the development phase. I'm hoping it to complete by end of this week. And yeah, these are some things which I've done in Sprint 2. So moving on to the challenges faced in Sprint 2, I faced a significant amount of challenge in testing part of the application. Right now, I'm manually taking all the values and compiling it into a netcdf file and comparing the panoply with the output produced by the web application, which is possible for the seasonal view because it's present linearly and it's just taking a year and month combination, which is quite simple. And when it goes to Enzo, if the user selects 1900 to 2014 and the seasons which fall under El Nino, which could be 200 or more. So if I'm trying to validate all those years manually, it will potentially take a lot of time to manually create that netcdf files. So which is something which I struggled on. To overcome it, I reduced the comparison year by five. So I'll be taking five values which lies between two specific years. Let's say if the user selects between 1900 to 1903, there will be potentially seven El Nilo seasons available. I'll probably take the permutation and combination of those 7 years and plot 5 6 maps depending on the outcome, and then I'll compare it with the output which is provided by the screen, and I'll make sure that the output is accurate of that produced by the panoply. And in the next sprint, I'm planning to use a semi-automatic testing process instead of testing every single month manually and plotting every single permutation and combination manually. And also in the next sprint, there will be a synergical tab, which will ideally gives the user the flexibility to compare all those uh, climate drivers, seasonal view, and monthly view. So whichever the user prefers, he will be able to compare. So it potentially will increase the number of permutation and combination of comparison between the application. So yeah, introducing a semi-automatic testing process will come in handy in the future. And yeah, I think this sprint through was a great learning experience for me. I get to work with a lot of the debugging process and the testing process, which really enhanced my skills and gave me a clear understanding of the basis of testing process. And that's my sprint retrospective. Thank you.